G'day chemistry students, in this video we are looking at dot point 7.2.5 and 6. Our focus is going to be on using organic chemicals in broader society as well as in the lab, and our focus is going to be on the impacts that they may have and the safety and handling precautions that we will need to take. Let's get into it. First off, I would like to look at some clips from risk assessments that I've already conducted for this module and some of the organic chemicals that we will be handling when doing practical activities. And the main focus is to pull out a couple of the more dangerous chemicals that we're going to be working with and just have a quick chat about some of the things that are identified in those risk assessment sections, because there is risk that can exist when handling organic chemicals. So first off, we're going to look at this chemical here called cyclohexane. Essentially, it's hexene, so 6 carbons in a chain with a double bond. That's the ene part there. The cyclo part means that essentially all of those carbons are connected in a hexagonal shape. What we can see here from our danger warnings is the substance is highly flammable, both the vapors and the liquid. It's toxic, and that could be from ingestion or even just from skin contact, or from excessive inhalation. That's this symbol here, by the way, that it can cause damage to respiratory and circulatory systems if vapors are inhaled. And finally, pouring it down the sink would be a terrible idea. It's toxic to aquatic life. So once it gets into our sewer systems and eventually our waterways, it probably won't decompose, and will have lasting effects to aquatic life. There's some further hazards and handling procedures that are also identified, but I'm going to be talking about them broadly in the coming slides. We're also going to be producing 1,2-dibromoethane. In fact, this guy is so dangerous that it's been given a teacher code for handling. It's a potential carcinogen, and that's the case for a lot of organic chemicals. Proving whether or not they are actually carcinogenic, meaning that they cause cancer, it can be quite costly, but it is assumed, or there may be some inconclusive studies that suggest that it is a potential carcinogen, so certainly something that you don't want to be in direct contact with. Toxic when inhaled, that's this symbol here. Toxic when in contact with skin or swallowed, that's this guy here. Can also cause damage to eyes and respiratory systems and just irritation in general. And again, not something to be tipped down the sink. Another substance that we'll be producing is cellulase. It's a polymer, essentially synthetic silk. This guy here can cause all sorts of damage to respiratory systems and promote asthma attacks, etc. if the little fibers that can be produced from the cellulase are inhaled. So again, something that we want to try and avoid. So the main ways that we can be exposed to organic chemicals and their harmful effects is through inhalation, contact and absorption through the skin or eyes, as well as ingestion. There are a lot of things that we can do to try and avoid those effects. One thing that we can do that is quite effective is use a fume cupboard. This will certainly mean that inhalation of fumes is going to be greatly reduced, but also if there's a large spill, it's going to also reduce our direct contact as well. In general, handling any chemical should be done in a well-ventilated area, especially if a fume cupboard cannot be accessed. When trying to avoid direct contact, wearing PPE is probably one of the most important things that we can do. That may include goggles, lab coat and gloves, but also we need to be using our equipment for containment as well. So effectively using our glassware, maybe our pipettes, beakers or test tubes to ensure that the chemicals are contained where they're meant to be and not getting everywhere where there's increased risk of contact. To avoid ingestion, the general rule is that if we aren't choosing to ingest the substances, then really the only risk is through indirect transfer to our digestive system, and that's through skin contact and poor hygiene. So as long as we're wearing, say, our gloves and then washing our hands once we've actually completed our work, we should be fine. Apart from direct methods, there are some other things that we can do to just generally prevent exposure and risk. One of those is looking at SDS, or safety data sheets, and what they recommend, and then actually implementing those in our labs. Correctly using PPE and other safety equipment such as fume cupboards. ensuring that we are containing and storing our chemicals appropriately, and also selecting an appropriate environment to use those chemicals in. For example, outdoors on a really windy day, probably not a great place to be using those chemicals. We want a controlled environment where we can contain those chemicals at all stages. And a lot of the time, the best place for that is a fume cupboard. We can also be preventing exposure and risk through the control of our use, really only choosing to use those dangerous chemicals only when they are necessary. We can also reduce the amount of chemical that we use. So especially in, say, a teaching lab, if we don't need to use 100 mils of an organic chemical and we can get away with using a couple, well, then we're going to pick to use a couple, not just from a cost perspective, but also from a safety perspective. It will reduce the amount of exposure and risk that we have. If possible, if we can choose to use a less harmful chemical and eliminate it, a lot of the time labs and industrial groups have eliminated the use of certain chemicals and have elected to substitute for a safer chemical instead. We can also reduce risk through automation processes. I've actually got a picture of one of those on the next slide. So in the middle here, we have a fume cupboard with a robot in it, essentially, that is able to conduct chemical work with some really, really, really dangerous chemicals. And essentially in that situation, risk of exposure is essentially null. We can also prevent exposure and potential risk by using our PPE carefully and effectively. Here as well, I thought was a pretty cool picture of an environment which is even more contained than our fume cupboard. So this container is completely sealed, and the only way to access is to put your hands through these special holes with gloves that sit at the end. A lot of the time, if you need to be using an environment that is contained as this, generally what that means as well is the atmosphere in here is probably actually nitrogen, and without the oxygen that's present, or the water vapor as well that's present in our regular air, if we're only using nitrogen, that's an inert substance that pretty much doesn't react with anything. So for those highly reactive chemicals, handling in an environment like this may actually be necessary. Included on this slide is a guide for the disposal of chemical waste. What happens first when we look at the disposal of chemical waste is we need to begin to classify substances and collect waste in particular containers. So one thing that we can do is sort by whether or not the waste is aqueous or organic. If it's aqueous, we can then sort potentially by their pH, meaning that we can neutralize those substances in like post-processing. If they're organic substances, what we need to then decide is a substance non-chlorinated or chlorinated? Those different kinds of organic chemicals, whether they have halogens or they don't have halogens, will get processed in quite different ways. So being able to separate them initially means that the later steps that happen in processing chemical waste are a lot simpler. We can also have containers for solid waste as well as specialized waste that's here in particular for really toxic metals. Something that I've just noticed as well that isn't on this page is a lot of the time aqueous waste that has heavy metals in it. So things that are probably even heavier than iron waste, metals that are heavier than that, elements on the periodic table, will end up having their own container as well. One big general rule for waste and disposal is, at least for organic chemicals, is to assume that they are toxic to aquatic life. Not all organic chemicals are, but it is better to assume that they are going to be toxic than they are not, because most are. And so therefore our general rule, our big rule is do not put waste down the sink. So when looking at our basic must-dos for chemical handling, organic waste, disposal and storage, we need to be ensuring that we store our waste with clear and explicit labeling. That way contamination doesn't happen. That our stored hazardous chemicals, from there we can actually send our hazardous chemicals that can't get processed in labs to disposal groups. Generally what they do is neutralize those samples first, filter for any kinds of solid waste that may not need to be there, and then go through a variety of chemical treatment processes depending on what kind of substances are being processed. Thank you very much, everyone. In the next video, we're going to be starting to look at chemical reactions. Once we introduce those reactions, we can begin to summarize them and conduct some of those reactions in class as well. The first sets of reactions that we're looking at are addition and substitution reactions onto alkenes. But until then, have a good one.